communication gap. So, okay, so before we go there to the communication gap and we study about around the communication gap, so let's see a very interesting subject, right? If you guys are staying in towns and cities, probably you know already about real estate. So is this presentation is about real estate or buffer overflow? So first we'll talk about real estate and then we'll talk about buffer overflow, right? So what is real estate, guys? What is real estate? So basically, in any city or any town, some builders will go around the city and they'll find some places, and then that place they will divide that into the small chunks. Okay, so after dividing it into the small chunks, then again they will, put few chunks. I mean, part of the chunk, and they'll name them as plots. Right, guys? This is called plots. So once you got the plots, then probably, slowly, um, probably, the colonies will get developed. And once the colonies got developed, then what will happen? Probably people will construct their houses over there, right? So once the houses are constructed, then, probably this is how they look. Let's say if a postman or Amazon delivery guy came to you, I mean, searching for your home, and then he wanted to deliver something in your house where is it 23rd. So how he need to check for the 23rd house? How to go there? So first he need to check first house and he'll ask, are you 23rd house? Then probably, you know, he will go to second house and then he'll check whether, is this 23rd house? No, third house, fourth house, fifth house, sixth, seventh, eighth, and so on. All the houses he checks, and then finally he reaches to 23rd house and then he drops the package. Right, guys? So this is how general real estate and then housing colony works. Right? So is this correct, or can we optimize the way of delivery? Is there a way to optimize the way of delivery? Yes, there is a way to optimize this delivery. So that's what we generally do. So rather than representing these in the continuous number, so we'll represent with a index number. What is it called? Index number or street number. So probably you will see probably Lakshmi Street or Gandhi Street like that in India. But if you in any latest or recently developed cities, if you look at, they'll be represented probably with you can represent with numbers, and then you can represent houses with again numbers. So let's say if you need to go to the same house, previously we used to call it as 23rd house, right? A 23rd house. So what you call now? 3 oblique or 3 dash 4. So now the same Amazon delivery guy, first he goes to the third street and directly he goes to the fourth house and then he checks into that house and then probably he drops his package, right? So this is how delivery system get optimized so that they can deliver fast with lesser work. So basically, by dividing these into streets, so we are making it more easier way of reaching to the houses. So this is called real estate. Once the colony got developed, that's all. Like probably it will become another part of the city, right? So now let's see what is memory estate. So this memory estate, where this happens? This memory estate happens on your RAM. So you might have heard about these RAMs, and probably if you ever saw any manually built PCs, you might have seen this RAM, right? So inside this RAM, what do we have? We'll have memory locations. That's where your whole data need to be processed or kept to get processed and probably displayed to you, right? So have you come across this memory, and what is the size of regular size that you see for the RAM? Generally we see the size of the RAM as like 1 GB, 2 GB, or 4 GB, or 8 GB, 16 GB, or 32 GB as such, right? So when you said 1 GB, what does it mean? these many bits it can set or reset. That means it can set this bit on or off, next bit on or off, next bit on or off. So as such, it can set these many bits. It will have these many bits on this whole RAM. And now, if you look at the processor, it got only 2 power 16. I mean, it got 16 lines if your processor is 16-bit processor. So you might have heard about these processors also. Generally, they'll be represented with the 16-bit or 32-bit or 64-bit processor. So that operating system, right? So assume that you have 16-bit processor, so that how many number of address lines you can represent at a time is 65,536. It is pretty simple, guys. We can only represent 65,536. Let's say Amazon delivery guy comes to your street, and then in your street you can have only 65,536. That's all. If it goes beyond that, you can't even represent. That's all. This is what he can represent. So one such okay street, or one such street, or the maximum number of locations that can be represented with a processor is called segment, right? So for example, a street can have at maximum 100, or probably will have 20 houses in a street. In the same way, a segment can maximum have 65,536. That is 2 power 16 bits. So if you take a 32-bit processor, how many locations you can represent? A segment is much bigger, 2 power 32, but still it is much smaller when compared to even 1 GB of RAM, right? So that's the reason why what will happen is processor will make it this whole RAM into the streets. Rather than using it in a one part, it will make it into small streets, which are called segments. Okay, what is the maximum size of the segment? It is 65,536, and minimum size of the segment you can take anything. For example, you may have in your street, you may have 10 houses. In the street beside your street, probably you may have 5 houses only. So as such, your segments can have can be smaller, like they can have 30,000 bits, or they can have 65,000 bits, and they can have 45,000 bits. So any size they can be, right? So now what processor does is it first releases one set of addresses, which is called segment address. So for example, this is first segment, second segment, third segment, and then there may be many number of such segments. Okay, so the address or the each segment index is called offset. Each segment is called segment index, and it will contain a offset inside it. For example, like in Rajarajeshwari Street, okay, my house is sixth house, right? That's an example. That's how I say. So let's say this is Rajarajeshwari Street, and then probably this is Lakshmi Street, right? So as such, you can have many streets, and one of such street, for example, if you wanted to represent a memory location, you can represent it here saying that 52,000. So there are two addresses that can be sent from the processor to locate any segment. One is locate any specific location. So that is first it sends segment address, so that it come to the directly to the segment. For example, segment 2, and then on segment 2 offset 20,000. It is exactly like for example, flat number or plot number 3, and then the street number 6. So it will come first to sixth street, and then it goes to the plot number 6. Or these segments can be at any size, so they can be smaller and they can be bigger. Does it make sense? Any questions till now? Okay, no answer. I hope no questions. No questions. Okay, awesome. So this is how your memory is managed inside your RAM. So let's little go in depth into the more um, into this memory management, right? So if you guys look at this specific screen, what is this player? VLC media player, right? And then what's the name of the movie? Any guess?
Ice Age.
Uh, Ice Age.
That's right, ISIS, right, exactly. So basically, let's say when you open VLC media player and then you would like to play ISIS movie, that movie file that you downloaded probably from Tamil Rockers or from the internet, that is called a data file, and the software that you are using to play this movie file is called code. Okay, so you have code must be stored in separate segment and data must be stored in separate segment. If both are combined or if data got confused as code, that's when the whole problem starts. That's when the whole problem starts. So they will be managed very, very intelligently and very properly. If there is a confusion, the entire application will crash. So let's see how it will crash and so on, right? So let's say when you clicked on VLC, first it loads that code that used to pick up the data and render it back onto your monitor or in your TV. That code will be loaded into the RAM first. Okay, and at one point what it does is it picks up the data segment, it goes to the data segment and it picks up your ISIS movie and it starts playing that movie till the end. And then once that data got processed, so it picks up one byte of data and then process another byte of data and process. So once it processes this entire data, then it will return back the handover to code, and then finally code will get closed. This is how a specific function will be called and data will be processed in any process. Like if you go to task manager, you will see a lot of processes. So all those processes are nothing but your code segments, and sometimes those processes will bulge, right? Those processes will bulge. Like if you look at the Chrome process, it will be probably occupying your 1 or 2 GB of RAM. So at that point in time, it holds a lot of data that it is occupying this much space on your RAM. Okay, so this is how any process generally executes. Okay, so any questions on this? Assuming no questions.
Please carry on.
Yeah. Okay, so you might have seen these abstract data types and then FIFO and LIFO, where FIFO is nothing but first in, first out. Whoever comes first will go out first, and then stack is last in, first out. So basically, in stack, what we'll do is we'll push we'll push things one after other, and then whoever goes last will come out first. Okay, so data can be stored in both the ways. Like it can be stored in LIFO, or it can be managed with the help of FIFO also, right? LIFO and then FIFO, right? But generally, we're gonna in this class we are going to study about Stack Overflow. So I'm going to teach about Stack Overflow now. Okay, so let's assume this is the program, right? Someone I think using. Please don't annotate annotate, right? Okay, so this is a C program that we have written, and I'm going to explain how data is going to be stored in the data segment. I forget about the code segment. I'm not much caring about the code segment for now, but I'll talk about more about data segment. I hope you guys remember where you're coming from, right? So we are going to talk about how this data segment is going to be handled. That's our story now, right? Let's say this is a small C program. I hope everyone can understand. So any C program must start with main, and then it goes first here, and then it calls for this function, and this function is passing couple of parameters here. Then those parameters, like 1 2 3 numbers it is passing, and then as they are numbers, we are catching them in the integer. And then in int a b c it is assigning, and then it's again declaring buffer 1 of 5. So it again declares character type 5 variables, and then buffer 2 of 10. So it again declaring 10 character type variables. After execution of this specific function, where it will go back, guys? Where it will go back? After completion of this function, it will directly go back to printf, right? And then it prints test and it comes back. So now I want you to analyze how much this specific function carries the data, like how much weight it requires, or how much data segment it occupies, and how it occupies. Okay, assuming the systems are windows and it is using stack or stack at this point in time. So stack will works in such a way that first come last out, or first last come first out. Okay, so now let's start looking at it. So first of all, it saves the function parameters that are coming as a incoming argument. So a b c it will store, or 1 2 3 numbers it will store. And then after that, it saves something called address of the address of where it left. Okay, so like that's called return address. So after execution of this function, where it needs to return? It needs to return back to printf, right? So it's calling for a function. After execution of this function, we'll come back to printf. So that printf address location will be written over there. Let's say if you go to, if you go to some other city or town, and where do you return back? You'll return back to your hometown, right? So this is like your next code address will be kept here whenever a function is called. And after that, it will store something called a saved frame pointer. This talks about the whole frame, so we don't need to much learn about it, but as it is saying pointer, it is another address. And after that, it will store local variables. So what are local variables? Is character buffer, and then buffer 1 and 2 are there, right? So both are called local variables. So by looking at, you guys can easily say that, so we'll have A, B, C here, A stored here, B stored here, and C stored here. And then a written address, the address of this printf will be stored here. And then it will store saved frame pointer here, SFP. And then what else will come, guys? Buffers, right? Buffer 1 and buffer 2. This is 5 bytes and this is 10 bytes. This is how it is going to manage your data segment. It's just not like loading movie, but it will put it in the memory or variables. Now even stacking out, while removing out also, it needs to remove in this way only, like first this and then this. So this is how it arranges its data. Make sense? Any questions? No questions, hope, right? Okay, so little more complex program, and anyone would like to probably help me in storing this tag. So rather than this time, rather than taking it in from vertical, I just picked it in from the horizontal side, and then as it is stack, I'm loading it from left to right, like from this side to this side. Okay, so I'll explain this. Probably any one of you can come out and probably explain that. So let's say we have much bigger function. So what does this is doing, guys? Anyone?
It's declaring 250 characters. I mean, for name.
Okay. Okay, and then what this is doing, Amrita? Next line.
I mean, it will give the output for and.
Okay, it's asking to enter a name, and then you're entering. Assume that I'm entered a name, and then what it is doing?
It's for string. I mean.
Okay, and it's okay, and then after that, it's stored in the string, and then after that, what happened? We're calling a function with a array. So what will happen? This function will get called. So we are looking for the memory allocation of this function. right guys? So now let's click next, and how many bytes it gonna occupy? I'm just calling it as bytes, but ideally it must be some memory locations. Assume that it is bytes for now. Okay, character byte basically. So now how many bytes it is going to occupy? As the size of the character array is 250, is going to occupy 250 bytes. Okay, and then after that, what will be there immediately after declaring the memory? So I just gave the function parameters. So what will come next into this place? Any guess?
Return address.
Exactly. Printf address where it needs to return, right? It'll get there to the return address, and then it will have SFP and then local parameters like buffer 10. So let's say it declares buffer of 10. Make sense, guys? Clear? So now assume that I'm entering Krishna, word Krishna. So as soon as I enter Krishna into this, it will go here. And then what this function does, guys? strcpy? String copy. String copy. It just simply loads this Krishna value into the buffer, and it will be written like this. Right? Right, that's all. It's simple, and then it goes to the return address. This is where you have this return address, and then it will come back and it will print that return to main, and then the program will close, no problem, right? In case 2, what I'm planning to do is I'm planning to put Vinita Krishna. Vinita is my wife, and when I put Vinita Krishna, let's see how this program handles, right? So I put Vinita here, and then Krishna, Vinita Krishna, and then what will happen next? Krishna will get copied from here into the buffer, right? How many characters are there in Vinita Krishna? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, right? Now, what is the buffer size of this?
10.
10. So when you copy it, this is what happens. This is what will happen. So it will get copied. It won't get stopped. Okay, in C program, it won't get stopped. But while copying, it will overwrite SFP first, and then it will overwrite return pointer. Okay, that's all. Copy happened. And after string copy, what do you need to do? We need to
Return.
So we need to return back to printf, right? So do you have address anywhere? This return address? Do we have return address somewhere? This place. Is that a return address now? That is when your system understand this address is not correct, and then it will pop up and show referenced memory location is not available or not able to identify in the overall server or in the RAM. So I'm going to crash this program and just close it immediately and recover all the memory locations that I allocated. So this is called buffer overflow. So basically sending a bigger data in which into a smaller place. So when you send, it occupies the next place also, right? So how many times if you go if you see people who are very heavy like me, so if you sat beside me, probably I'll occupy some of your place, right? So that's where this you can take this as example, right? So heavy people will occupy the next seat of in the movie theater or somewhere, right? In the same way, when buffer overflow happens, it will take it will override the return pointer, and there is no way to go back to the actual printf. Okay, so this program won't execute this. I just gave it for the example, but it will crash immediately as soon as you run it, even if it executes. Okay, so now this looks interesting. So what I did is so this is called a buffer overflow, and there's a crash with the help of buffer overflow. Once the program is cached, it won't execute anymore, right? And then now the third case, I'm planning to put system of dir. Okay, I'll take bigger buffer. I mean, to make it clear, I made this program smaller, and then to look it better, I just made this horizontal RAM, or like, bigger, right? So let's say we have 0 to 250 locations, right? And then as we defined again the same thing, 250, and then two more locations, 250 to 252, and then 254 for SFP, and the remaining 10 for the buffer. So as I said earlier, I'm going to put system of dir. By the way, what is system of dir, guys? What is system function in C does? System C function does? It's a C function in right? What it does? You can guess it.
It opens the dir location.
Yeah, I don't open dir, but it will actually show you the dir like, dir is like directory listing. Basically, it will show you the directory listing. So you can put anything inside the system. Inside the system, if you put notepad, it opens notepad. If you put some process, it will open that process as such. So instead of entering, any name, I entered system of dir and then semicolon and 12. So what is this is called? When we supply input, what it is called, guys? This is called data, right? So like Krishna is a name, which is data, and Vinita Krishna is again name, it's a data, and then system of dir semicolon 12 is again a data. So I supplied this data into the buffer, like first thing, right? And then a return point, like, so what it does, it will get copied from name to buffer, and now it overflows these two characters, right? It wrote system of semicolon and 1 2, right? So how many characters are there total? 1 2 3 4 5 6 7 8 9 10 11 12 13 14. So it overflows exactly, this 12 exactly comes into the return pointer place. So when it comes to the return pointer place, so after loading this data, it needs to come back to where it needs to come back after executing this function. It need to come back to printf return, but printf returned address is overwritten with the address 12. Okay, so what it does is, as there is nothing in the SFP, no proper data available in the SFP, very carefully crafted payload like this, it moves your location from this point to 12 locations ahead. So from here, it goes to 264. As per the system, where it reached actually, it reached to the code segment, but it is still in the data segment, as it thinks that I return to the 12 addresses locations. It thinks I return to the code segment rather than executing printf. Now it starts executing system of dir. Or if you put system of notepad, it will start notepad. If you put some other payload, it will start executing that payload. Okay, so this is called buffer overflow with RCE, remote code execution. There are two cases. Case one is buffer overflow can lead to the DOS, denial of service, in which the attacker is going to take over the whole control of the entire. Sorry, in case of DOS, the server is going to crash so that there's no more service available. In case of RC, remote code execution, you can convert your inputs, or your inputs as code. System perceives them as code and starts executing. So whatever you send data, it will become code. Okay, as I said earlier, the entire problem in the security is because of this. If you look at cross-site scripting vulnerability, data is considered as code in the JavaScript, right, in the browser. And if you consider SQL injection, data is considered as code in the database. If you consider command injection, data is considered as code in the application server layer. If you consider buffer overflow, data segment is considered as code segment, and it starts executing that. okay, which is called buffer overflow. So let's see some practical examples. So I have something called Easy Chart Server. You can get it, version 2.1. So you can get it and install that Easy Chart Server over there, like any of your, probably in your instances. And then what you guys can do is you guys can actually connect to the server once you install over the browser. So you can open that server, like server IP address over the browser, and then browser immediately, and when you open that server address, it will immediately load that easy chat room space. So this looks somewhere like something like this. This is exactly how easy chat server looks, and where you can, you are just accessing the server IP address and then with some port number, and then you can actually register yourself. You might have seen a lot of chat rooms that were, they're in probably late 2004 and all. So this is how they look, and then you can put your name here, like if you fill this name, and then your password you can give your password, and then you can simply submit this request. So once you submitted this request, it goes to the server, and then it registers, and then it allows you into one of the room, or you can actually switch between the rooms and so on. There's a lot of functionality around it, but the first where it starts is you need to enter your name and then your password. So once you registered, you can chat with the other people, right? So like when I said you can chat with many other people, will come like this and then connect to this, that, and then they authenticate, they create their own usernames, and then you probably can join into the groups, and then you can start conversing, right? So that's how this general chat works as well. Chat works. So everything works fine till the time attacker comes into our story. So here you go. Here we have our attacker. So what this attacker did is, so how many fields do we have in the input, guys? Here there are two fields, right? One is name, the other one is password. So instead of entering proper name into the system, what he does is he simply enters a long string, a very, very, very long string. Like you can put all yes, yes till in the post request till the end, and probably ampersand password also he puts, and he sends this request to the server. As soon as this request is sent, and what will happen? By looking at these A's, so first thing, it tries to load these A's into the data segment, and these A's will at one point they'll overwrite your return pointer, so that it can never get back to the actual function. So the application will immediately crash. Once application crashes, right, it's gone. So no one else can communicate with the server, everybody goes offline. So that's how you can actually create denial of service with the help of buffer overflow. You kill this guy, right? One shot with all yes, this guy is gone, right? The server is basically gone, right? So this is, we are going to see this practically. So before we see this practically, or the demo, so let's go ahead and understand another place where I'm planning to implement RC, right? Remote code execution with the same buffer overflow. So this is called disk pulse server. So we have multiple servers like that. So what these disk pulse servers do is, they'll be in the corporate networks, across the corporate networks. So they will connected into the machines of every employee, every user, and then they'll start observing each and every file. If there is a change in a file, right? So if some malicious program changed any file or tried to access any file, right? So any such changes will be detected and they will be logged by disk pulse. So basically it observes the disk, and any changes it will observe and log, and then you can produce a report, right? That file is copied from this place to that place. So as such, at the enterprise level, you can produce the report. So if there is any data tampering happens, if someone copying the file, as such, all those things can be identified with the help of disk pulse servers cluster. So if you look at it, there can be clusters or there can be a single disk pulse, and then you can pull out the reports with the help of all that, right? So to make it much easy, I'm going to remove a couple of components and have only few components that is required. So one is disk pulse server, where it observes all the data logs, and then user can actually see that with the help of GUI. So there's a specific client where you can connect to this server and you can retrieve data, and then you can present it, or you can pull some data like which user changed which file, all that you can manage. Okay, now this, let's say, so basically this also uses HTTP protocol at the back end. So let's say this is my attacker machine, and this is disk Pearl server, and then this is our attacker machine. Now what attacker machine is going to do is, I'm going to use this specific payload that was developed by our engineers. So if you observe, there's very important part in this payload is, though it is written in Python or any other language, so basically it sends a get request to the server. So you can clearly observe this, right? So one of the header is get, and then slash dot dot slash, and then percentages. So where do we have this percentages definition? We have this as a payload. So this is basically a get request. This is basically a get request to this server, which is, in the get request, I'm adding this use payload. So if you want to see what is payload, like if you look at the second line here, what I'm doing is I'm writing a, how many times? 2492 times, and then I'm concatenating some extra buffer which I'll call as payload, extra payload, and then that I am sending a get request to the server. So what extra buffer I'm attaching is, I'm attaching something called reverse shell. Okay, this is called reverse shell. Basically the extra thing that I added is called reverse shell. So what this reverse shell does is, it connects back to my local host, my attacker server, and it gives a complete access on this machine. So basically what it is doing is, this payload is going to override the return address in such a way that it executes my program, my reverse shell, and it gives the whole control of the victim machine to me. So when we execute this program from the machine or the attacker machine, it sends a get request with this payload, which will initiate a return connection to me, and this will compromise the whole machine. And my Kali Linux machine or my attacker machine, which is running with netcat and listening to a specific feed, will get a reverse connection, and I can access command prompt of the victim machine. Right, guys? So that's how I can get the whole system access. So I can get C drive Windows System 32 of the server of the disk pulse. Like, if you have disk pulse server, the disk pulse server works normally, but it will overflow, and I can take the full control of this machine. Right? In this way, with the help of buffer overflow, we can create RCE, and also we can cause denial of service attack. So these are the two major problems. And generally, if you look at the any CVSS rating for this, it will be given 10 out of 10, because you'll get the entire system access on the victim. Any questions till now? Any questions, guys? I hope there are no questions, as no one is asking any questions. So let's see something practically, so that you guys can understand. So I'll hand over to execute this demo. I'll hand over my control to Parthu. Parthu, are you there?
Yes, Krishna.
You can
Okay.
take over the stuff.
Please confirm if you're able to see my screen.
We can see it, Parthu.
Okay, yeah, perfect. So yeah, as Krishna mentioned, like we have two different missions. One is the Kali mission, which is from the attacker, and we have a Windows 7 mission, which has both the binaries. The first one is the EasyChat server, and again we have the disk pulse utility as well. So we'll try to see the first scenario, that is the crashing the EasyChat server. So let us start the server. And then here we can clearly see that the server is running on the port number 80. So to verify that, let us open the browser. Okay, since it's running on port 80, yeah, here we can clearly see that the EasyChat server is running perfectly fine. So now we already saw the scenarios like how we can actually crash this particular chat server. So we already have the pre-built scripts based on the time. So we all directly executing the scripts. So this is the piece of code that which we have written in order to make sure that the buffer overflow happens and it can crash the entire server. So we have run the script in the Python, and here we can primarily see that we are using multiple modules, and one of the main module is socket in order to make sure that we are establishing a connection from the attacker mission to the Windows 7 mission or the victim's mission. And you might wonder, like, what exactly is this piece of code? So it's a shell code, which we'll be discussing in detail during the buffer overflow class. And this is generated using MSFNM. And also don't worry about that, because that also will be explained in detail. So using the shell code and all these different connections, we are able to make a socket connection to the Windows 7 machine in where the chat server is running. So if you see in the start of this application, it accepts one argument. So that is the IP address. So the way how we can run that is Python chat bufferflow.py and the IP address 10106, which is the IP address of the Windows 7 machine. So the moment when I run this, here it shows blank. But if I go to the Windows 7 machine and if I try to refresh it, it doesn't even open at all. Because by executing the particular program that what you have written, it crashed the entire application. So you might think, okay, so what's the big deal in that? It just only crashed the application. But that's where we go into the next binary. So the next binary which we're going to explain is the disk pulse client. So this is the remote and as well as the local monitoring solution for the disk health and the utilities. So right now we'll see on which particular port is the client running on or server running on. So we go to the advanced options, and if you click on server, we see that the server is running on the port 8080. So now again, let's go back to the attacker mission. And let us see the piece of code. Yeah. And again, here also we see that the code is written in Python, but instead of one argument, we are giving two different arguments here. The first argument is the IP address, and the second argument is the port, the remote port in which we need to connect back to. And this piece of shell code we have generated using MSFNM. MSFNM is a part of the Metasploit framework, and you can see the actual code using which we have created this shell code. So we use MSFNM utility, and we are trying to get a reverse shell. So you might be wondering what exactly is a reverse shell. So reverse shell is a kind of shell wherein, let's assume this is the attacker and this is the victim. So the victim, once we execute the payload, it tries to connect back to the attacker in whichever port we are mentioning. So here we are mentioning the port number as 9090. So it means that once if we execute this particular payload, then it executes on the remote mission, and then the remote mission tries to establish a new connection back to our own mission. So for the purpose of that, I'm opening a new instance of Kali. Yeah, and I'm using a utility called netcat. So netcat is a small command line utility wherein you can try to establish a connection, and also it is as simple as that, wherein you can do a small chat functionality, or even you can transfer the files. So a lot can be done using netcat. So netcat has multiple modes. So the first thing is listen mode. So listen mode is like, okay, I can say like, okay, use the netcat to listen on this particular port. And also I'm giving the next command is V. V is the verbose. It's like to give the detailed description of each and every log. And finally, I need to give on which port it needs to listen. That is the port number. So if you see on the previous screen, the port number which we are trying to listen is 9090. So here we need to give the option as 9090. So essentially what we are doing is we are listening from the attacker mission on the port 9090. So the next part what we need to do is we need to execute this particular payload and crash the remote application. So one thing here. So instead of crashing, we wrote a script in such a way that without even crashing the application, we directly get the entire access to the Windows 7 machine.
Adding to Parthiv, sorry for
Yeah, sure.
stopping in between. So if you look at last to eighth line, right? So where you can have packet is equals to get off slash slash and percentage s, right? After that, if you put it like, look at payload. So basically in the URL, we are sending the whole payload that we constructed. So the whole payload job is to get a reversal on the server, which is running on Windows 7, and connect it back to the Kali Linux, which is listening on NC. NC is nothing but Netcat. So thanks, Parthiv, returning to you.
Yeah, thank you, Krishna. So, and again, adding to that, so you might also see a couple of other instructions here. So every Windows system, let's say it's a 8-bit or 16, 32 or 64-bit, like you commonly use, right? So every kind of Windows system has a different kind of architecture. So for every architecture, we have different kinds of instruction set. It might be, let's say if we have a 32-bit application, we might have EAX, EBX, or for the stack pointer, we have ESP. So by using these different instructions, we can modify the payload and then we can execute. So without any delay, I'm just going to the execution part. So as I said earlier, like it requires two different arguments. The first argument is the IP address and the second is the remote port it's running on. So this is the IP address, and we have seen here that it's running on the port number 8080. And also we made sure that we are listening on the port number 9090. So let's execute it. It says the connection success. And yeah, the application also works fine. But let's go to the again attacker mission and see what happens. So we got a direct shell of the remote mission. So let us verify if it is a remote mission or not. So I'm using a simple command called ipconfig in order to see the IP address of the remote mission. Yes, it is the Windows 7 mission. So right from the Kali mission, just by executing a simple buffer overflow payload, I'm able to connect to the Windows 7 mission, and I'm able to get the command prompt of it. And also let's see what privileges we are in. So for that, I'm using a command called who am I. And here we got the response as NT authority. So for those of you who are not sure, so NT authority is the highest privilege within the Windows operating system. It is as similar as the root permissions within a Unix or a Linux environment. So this exploit clearly shows us like what can be the damages that which can be done using a buffer overflow exploit. Any questions till now? Okay, I take the and I'm giving the control back to Krishna.
Sure. Thank you, Parthiv, and I hope you guys can see my screen, right? So basically, you have seen a lot of things like, I know it's a very heavy loaded session, but let me quickly, show you what we did and what we learned. So basically, we learned about how, written pointer can be overwritten, and then how we can take it, or how we can take or use it for taking the whole control of the system. So Parthiv actually in his first example, he crashed the server, and so that it won't respond to anyone else. Okay, and then the second example, what we did is we kind of took this server, and then we send this payload, and then this payload allowed us to connect back to the victim server. So now, as Parthiv explained, this looks like very complex, right? So but it's not as complex as this. It's very easy, and we are going to construct line by line of this payload in our actual training. So this is a demo for the training where we just showed you this payload, right? So in the same way, we are going to explain you how we set return pointer, or how we set payload, how to build this payload, where to build all that. There's something called ABCD. So what we use for A till D, like how we use everything, we are going to explain very in depth and very in detail, right? So in addition to that, as we in our syllabus, if you look at our training program, network and infrastructure penetration testing, we are going to cover basics of bash. This is to ensure everyone is up to the mark with Linux, and they can use, so that they can use Kali better. And then Netcat is going to be introduced as a module too. So we use Netcat a lot. If you guys observe, when the reverse shell came back, we got connected with the help of Netcat. And then we are going to show you the Netcat communications with the help of Wireshark, and more detail how TCP works and all that we are going to explain. And then we use for ports